are expressed through numericals. So when we work out more numericals, things will be easier for us. No. So there's a monochromatic source. So two mirrors M1 and M2. Two mirrors M1 and M2 make an angle phi with M1 and M2 make an angle phi with the line AB. There's a line AB. A point source S is kept at distance R. The distance is a small r from the point of intersection of two mirrors. A small hemispherical annular mask. So what will do? It will block the light. It will not permit the direct light to reach the surface or a screen. There's a condition. A small hemispherical annular mask is kept close to S so that no ray emanating from S directly reaches the screen kept at a distance B from the source. Interference pattern of rays lifted from M1, M2 is observed on the screen. Find the fringe width of this interference pattern. Okay, earlier the mirrors were horizontal. Now let they be inclined. He's asking to get the fringe width. Okay, now directly get into the ray optics. If you keep a source S at a distance of M1, so we know this distance is how much? This distance is how much? It is equal to R. The distance from AS must be equal to R. AS is equal to R. Then from the triangle sine phi, I think let me write few. Okay, triangle SM1A is equal to sine phi is equal to R sine phi. Oh, okay, the distance is needed, no? Sine phi is equal to SM dash by AS. So what is SM dash? AS sine phi. What is AS? AS must be equal to R. Okay, I agreed, no? So what do you mean by SM dash R sine phi? Okay, I wrote like this. Similarly, SM1, because the angle is phi, no? So we can also write it as M1, no? I think it's M1, so here. M1 it is. Similarly, this is also equal to SM2. Let's have it that first, have a clarity that one. No, how the, for a plane mirror, what is the basic condition? Object distance must be equal to image distance. Let me go take help of highlighter. Pointer not visible. We'll take the bigger one. No. So there's object distance. Object distance should be equal to image distance. So R sine phi should be equal to R sine phi. So what is S1 M1? Earlier what we wrote SM1. Now S1 M1 should also be equal to R sine phi. Similarly, SM2 is object distance. And what is SM2 from here? R sine phi. So therefore, object distance should be equal to image distance. Got the idea? So now where the mirror M1, M2 will form the image of S at S1 and S2. Okay, now we'll calculate this distance S1, S2, that one. So for that, I'll take help of this triangle. So looking at the triangle now, so what is the triangle? S1, M, S1, M, S, S1, M, S. In this triangle, what is cos phi? Cos phi should be equal to S1M by S1S. What is S1S? R sine phi plus R sine phi, 2R sine phi. So what is S1M should be equal to? Total this length S1M should be equal to. Total this length S1M should be equal to 2R sine phi cos phi. And look at this one. S1M should be equal to S2M. This distance should be equal to this distance because these two are similar triangles. So now this will become like a distance d between the slits. So these two will be able like a as soon as images will be able like a point sources of light, coherent sources of light. So what the distance d is equal to now 2s1m. Do we know s1m 2r sine phi cos phi? So 4r sine phi cos phi. Okay, I got the distance d now. Agreed. This one. Okay, directly I'll go for the fringe width. So for that, what should be the capital D? Capital D is what I'll measure from A to screen. That everything should be the capital D. So what is capital D now? Capital D should be like a R plus B. Okay, okay, wait. Capital D should be like a MS plus B, that one. Okay, this distance is MS and this distance is what? The B. Because here you can assume like screen is present. So what is the total distance will become? MS plus B. What is MS? MS, okay, I'll calculate here from sine phi is equal to MS by S1S. And what is S1S? Should be equal to 2R sine phi. So from that, I'll get the MS value. So what is MS will be 2R sine square phi. I'll write down that one. I'll get the fringe width. Okay, some mirrors, if they are inclined like this, yes, it will become some little bit some using mathematics. What we are calculating the distance between the images S1 and S2, and I'll calculate the distance of the M from the screen. So this distance will be capital D. What is the capital D? The capital D is not should not be measured from source to the screen. The distance of the vertical plane in which the slits containing to the screen, that should be the capital D, no? And if you go back to the YDSC, so how you measure capital D? If this is the slit S1, this was the capital D, no? It should be. So this is the point in, this is the point on the screen. Okay, call this is some O or whatever be that. This everything should be the, so I'll extend the diagram. Okay, I think now things are very clear for you. This is the screen. So what is the capital D? The capital D is measured like this. So definitely what is capital D should be equal to MS plus B. What is MS? MS is from the diagram is what we are finding out from this one. So this will be your answer. So these are some various ways of testing students, like the mirrors, the orientation of mirrors. No, Lloyd's mirror is the one experimental thing. These are like a numericals. So what is this? This is like this is not like a concave mirror. It's a opaque. It will block the light. The blue color one, what you're seeing. Got the idea? So these are the types of numericals. What happen? You should be ready to encounter in exams.